I want to once again welcome everybody to the Johns Hopkins Engineering for Professionals online information session. This is for chemical and biomolecular engineering. My name is Ken Chappell. I'm the Director of Marketing, Recruitment, and Communications. And I'm joined this evening by Dr. Michael Beaton Banton. Michael, you want to say a quick hello? I think you're still on mute.
Hi, Ken and everybody. Sorry for the delay. Can you hear me okay? Welcome to Johns Hopkins. I'm happy to talk to you a little bit about our program and then answer any questions. Okay, it takes me a little while to hit the mute button, so I apologize.
Not a problem. We can hear you just fine.
Okay.
So just a quick rundown of tonight's agenda. I'm going to start off with an introduction to Johns Hopkins Engineering for Professionals, just to give you some context as to how we fit into the university. And then I'm going to turn it over to Dr. Beaton Banton, who's going to walk you through the chemical biomolecular engineering program, give you an overview, talk about the admissions requirements, and so on. Then we'll talk about next steps for interested students. What does it take to apply? When do you register? Some of those logistics. We'll do a live Q&A. And the way we're going to do that is you'll see there's a questions tab on your control panel. At any point during the evening, go ahead and type your questions in there. We'll wait till the end to answer them, but we don't want you to forget along the way. So go ahead and type those questions in as they pop to your mind. And then we'll conclude for the evening. So to start off, how does EP, or Engineering for Professionals, fit into Johns Hopkins University? This diagram gives you a nice little snapshot. The area in blue shows you Johns Hopkins University as a whole, and there are 9 schools, one of which is the Whiting School of Engineering, and that is the school within which Engineering for Professionals lives. As you can see in the green area there, the Whiting School has full-time graduate, undergraduate, research centers, etc. And then off to the right there in orange is our division, Engineering for Professionals. And essentially what that means is we're the part-time and online graduate programs of the Whiting School. We recognized a long time ago that there is a need out there. Not everybody wants to go straight from undergrad into grad school and do it full-time. A lot of folks finish their undergrad, they go out into the workforce, and whether it's 1 year later or 20 years later, they decide, I want a master's degree to help propel me to the next stage of my career. And that's where we come in. We recognize that people don't want to leave their job to do that, so we need to either offer classes in the evening or online. And we'll talk a little bit more about that as it pertains to the chemical and biomolecular engineering program. But when you look across Engineering for Professionals as a whole, we have degrees such as computer science, space systems engineering, cybersecurity, mechanical engineering, and so on. And a lot of those programs can actually be done fully online. We'll talk about whether or not that pertains to ChemB, but just want to give you a little bit of a sense of how we are organized as a division. So who are we? Well, we are Johns Hopkins Engineering. As you saw in that last diagram, we are a full part of the Whiting School. And when you earn your degree with us, it will say so. It's not going to say part-time. It's not going to say online. It's not going to say anything like that. Essentially, it'll say Johns Hopkins University, Whiting School of Engineering, Master of Chemical and Biomolecular Engineering. So it's very much on par with what you are seeing at the full-time level. We just offer a little more flexibility and some slight changes in curriculum, but we'll talk about that later. One thing I'll also mention is that Engineering for Professionals is the largest part-time and online master's degree program in the country, and that is based on enrollments. And some of our programs are quite large. Computer science, for example, and systems engineering are quite large programs. ChemB is probably on the smaller side relative to the programs that we offer. So where do our students and faculty work? Now this, again, is a snapshot across all of our degree programs, but we have a lot of students and faculty who come from Raytheon, Northrop Grumman, the Johns Hopkins Applied Physics Laboratory, and so on. We've got some private industry in there, some government, some nonprofit, but it's a nice mix of you know, large industry, small industry, public and private. And so you'll see that reflected in a lot of the classes that we offer. So just wanted to mention that. So with that, that's sort of the context part of the evening. I'll now turn it over to Dr. Beaton Banton, and he will walk you through the finer points of the ChemD program.
Okay, thanks. Thanks for the introduction, Ken. My name is Mike Beaton Banton. I've been a faculty here for over 25 years. I've run the part-time or Engineering for Professionals program off and on for 10 to 15 years of that, so I'm very experienced. It's gone through a number of permutations and changes. We're constantly trying to adapt the program, and we certainly encourage the students, if there's a course that you're looking to take and you don't see it on the list of the course listings, certainly encourage you to seek me out and talk to me about that course and whether it can fit into your program. As Ken said, we have a range of different programs. We have undergraduate programs. We have master's programs of many different flavors. We have a master's program in which the students do a thesis. We have a master's program in which people do primarily coursework, and the EP program figures mostly into that. Students, though, if they're interested in doing a research option, they can do that through the coursework framework. And then, of course, we have our PhD programs. One of the great things about the EP program is that all the courses, or the great majority of them, I shouldn't say all of them, the great majority of the courses you'll be taking alongside of the full-time master's students, also the many of them the full-time PhD programs, and you'll be taught for the most part by 90 to 95% of the courses will be by full-time lecturers or staff or faculty from the Department of Chemical and Biomolecular Engineering. There are a few, we have several lectures that are involved in the program as well. We also encourage you, of course, to take some courses from outside of chemical and biomolecular engineering. Go ahead, next slide. So we have two focus areas within our program, and really I should really rephrase that. It's really three focal areas. Ken, I'll tell you when to go on to the next slide. You have a general Master of Chemical and Biomolecular Engineering that you can obtain through the EP program, and then you can also, if you'd like to, you can specialize. You don't have to. You can specialize in either biotechnology or nanotechnology, or certainly a cross-section of those two. And the difference in those is really just the number of courses that you take in a certain area. There's no real restrictions or limitations. This is just an opportunity to give you flexibility if you'd like to do one of the three different flavors of the degree. The degree is the same. It provides the same information. There's just a specialization, which I don't believe appears on the degree, but you can certainly include that in your CV or other material. So where this comes from is that we have a lot of we have faculty that specialize in these two areas, and so we thought these would be two great areas to provide special focus for our master's program. Okay, let's go ahead and go to the next slide. And certainly ask us with your put questions down. One of the questions, I'll kind of digress a little bit, that Ken alluded to is the difference between those degrees, between the full-time and the EP program. The difference is for the EP program you take 10 courses. The full-time master's program you take 6 courses and you do a research thesis. but you certainly, if you do the EP program, you can do a research coursework, so you could substitute one of your courses as research in a laboratory with one of the faculty members. I've had several EP students do research projects with me, and it worked out fine. In terms of the way, and this was a question that came up many times in the last year's session, so I figured I'd go ahead and address it as part of the description, is that as far as the outside world is concerned, the degrees are essentially viewed equivalently. They're both Masters of Chemical Engineering from Johns Hopkins University. One of them is called a Master of Science, and one of them is called a Master of Chemical Engineering, but for 90% of all situations, they're viewed equivalently. So you don't need to really worry about that, but I'd be happy to answer more questions about that. It's just what the student prefers to do in order to get their master's degree. And with the EP students, it's very difficult, of course, to do a thesis-based master's, so they typically focus on the EP program and the 10-course program. So who comes into our program? Once again, I wanted to emphasize that things are changing. They're very different than they were even let's say 10 years ago when I was involved in the program. 10 years ago when I was involved in the program, the predominance of students typically had a bachelor's degree in chemical engineering or biochemical and biomolecular engineering. Often biomedical engineering are one of the disciplines closely related to chemical and biomolecular engineering. And that still forms perhaps about half of the students in our major. Students that are working around the Washington, Baltimore area, students that are looking to move up in their jobs. So that's certainly a large part of our core as well, continues to be part of our core, but more and more now we see up to as much as 50% in some classes will come from other engineering or especially science disciplines: biochemistry, biology, chemistry, physics, biophysics, environmental engineering, biomedical. That's just a few of the fields that students feed into. And what they see is the flexibility of a chemical and biomolecular engineering degree gives them in terms of career opportunities and career options is why they go ahead and embark on an EP program from another science or engineering discipline. But because of that, that's going to require some prerequisites, which I'll talk about on the next slide. I don't want to get to that yet, but we'll talk more about that, especially for those students that come from an outside major. At the current time, our courses are primarily in-person courses. We think the students enjoy that in-person experience, but some of our courses are beginning to go online, and at least one of them will be online, we believe, in the next year or so. In addition to that, there's a number of online courses from the biotechnology program, from other engineering courses, so you could take almost all of your outside courses, outside of the departmental courses, online, and then take only the department courses at our Homewood campus. In terms of GPA requirements, we look for students that get around a 3.0 or higher in technical or science degree. We focus primarily on that GPA of the science, math, and technical courses, engineering if you have them. So if you have a GPA of around 3.0 in biochemistry, biology, that's what we're looking. That's what we're typically looking for. Doing a B average work in the science and technical courses. As Ken has mentioned, there's no GRE required. Next slide, please. So because we have so many students coming from a range of different backgrounds, and then we want them to be able to go out to the world and with the insignia of Johns Hopkins Chemical and Biomolecular Engineering, for students that come from often a non-engineering major, they'll have to pick up some courses or competencies in some of the core disciplines that they'll need in order to be practicing chemical and biomolecular engineers and to succeed in our program. And 4 of the areas are just listed here. One of the core competencies of engineering is thermodynamics. Students in chemical engineering will take a chemical 1 or 2 thermodynamics courses. So the students that we bring into our program, we expect expertise in that, though we certainly improve that when they're here as part of the program. Kinetic processes, often accompanied by reaction engineering, is another one of the core competencies of chemical and biomolecular engineering that our students must have, as well as transport phenomena, which includes fluid mechanics, mass and heat transfer. We want students to have some competency or undergraduate training in that, and then advanced math, calculus 1, 2, and 3 through differential equations. When we talk about these courses that we're talking about undergraduate competencies in chemical and biomolecular engineering. So how do you obtain that? Students do it all different types of ways. Most students do it through taking undergraduate courses at their local colleges, often in terms of if you're talking about the advanced math, you can take that at a community college. If you're talking about thermodynamic kinetics and transport, that's typically through some type of engineering discipline, either associated with their undergraduate degree, or if they had an undergraduate degree that didn't take this, then they pick up these courses on a part-time basis at a local undergraduate chemical and biomolecular engineering program. You can certainly take these courses at Johns Hopkins University, though that's not required, and we don't. That's not an entrance barrier into the course. You could take one if you're in Maryland. You could take them at UMBC at College Park. If you're in New Jersey, you could take them at Rutgers or Stevens or many of the places in New Jersey. So you can pick up these core competencies and in courses in many different places. In addition, if you're a chemistry or biochemistry major, you might have had some of these, or physics, you might have had, or other engineering, you might have had some of these basic courses as part, or mechanical engineering, you might have had some of these courses as part of your basic undergraduate program. A chemistry major might very well have taken a thermodynamics and kinetics processes. A mechanical engineer might have taken a transport phenomena or 2 courses. So we require, it's up to you to be competent in these areas. I will check it out, but it's really, it's your success hinges on your competency. I have had cases where students demonstrated to me through independent coursework that they were able to do that. But that, that can often be challenging and is an atypical way to approach. So some way to demonstrate competency through coursework or other training in these 4 areas. And this gives you the foundation that you need to be a successful chemical and biomolecular engineering, and there's a reason that our graduates are sought out, and that's because of these expertise in these different areas. So that's the background undergraduate requirements that we have. So let's go on to the nuts and bolts of the program. Many of you will, go ahead, Ken, next slide. Many of you will go directly into the program, especially those with chemical engineering or a related engineering major. Those of you that have a biochemistry or a chemistry major, you might take a year or so to get those core competencies down. But everybody tends to be able to get through that in a reasonable amount of time. So our degree, the Hopkins Engineering EP degree, is a course-based program. We require 10 courses to complete the degree. We have 3 courses that we recommend all students take. In the past they were required, but we found that would give some inflexibility to the students, so we're making them recommended and not required. And then you have the opportunity for 7 elective courses. A certain number of these 10 courses are required to be completed within courses within chemical and biomolecular engineering. It's varied a little. It's either 5 or 6. The number escapes me right now, but basically roughly half of your courses must be completed within the discipline of chemical and biomolecular engineering, and then the other roughly half of the courses can be taken from any. They have to be approved by myself, but they can be taken from up to 3 of them, I believe, can be taken from the biotechnology program at Hopkins. They can be taken from our environmental engineering program. They can be taken from our biomedical engineering, many of the programs around campus, mechanical engineering, material science. And students often do that if they're excited about a course in another, an EP course in another major. I say go for it, as long as it fits into the guide. Some students will take courses that involve management. This is a chemical and biomolecular engineering course. I permit maybe one of those courses, but it is a technical course, so we prefer you to focus on primarily technical related courses. Okay, I think that's good. Next slide, please. The 3 recommended courses that we encourage, the first is Metabolic Systems Biotechnology. That's a course taught by myself on Friday afternoons, and we typically have 1 to 2 EP students in the class of 20 to 25 every year. And this is a course where we try to take the quantitative concepts that you've learned in engineering and apply them to biological systems. We have another course which is Interfacial Sciences. It's primarily for those that have a interest in nanotechnology, though we want all our students to have that, so it's a required course, but it looks at the interactions when you go to smaller and smaller sizes, the area to volume ratio increases, and so this interface phenomena between the boundaries of solid and liquid, solid and gas are important, and so understanding this relationship between interfaces is important in nanotechnology and many other fields as well. And finally, we offer a course in chemical reaction engineering, which is taught by one of our lecturers, Carmo Pereira, who unfortunately couldn't make it tonight, but he teaches a number of EP courses, and he's a full-time PhD from DuPont, and really is an expert in many of these different fields from up in Delaware, and helps us out with that. Next slide, please. In addition to these EP courses, you can take courses around the campus to fulfill your outside the department. You can take courses inside or outside the department. As I mentioned, about half of them can be outside, but a number of them have to be inside the department, approximately a couple of them out after those 3 recommended courses. And these are just some of the different courses that many of our master's students have taken. Students that are interested in medical biomedicine and the pharmacology of delivery of medicines through the body. There's many chemical engineering concepts in there. They'll take project and design, pharmacodynamics. We have a very popular course that's offered in the evening. I think this is co-taught by one of our full-time faculty and a professor at a PhD from DuPont, and that's in nanomedicine. We have up to 70 students of them, and a number of them are EP students. We have a micro nanotechnology course, and bioengineering and regenerative medicine, as well as nanobioengineering laboratory. So those some of the different options that you can take within the department, and that doesn't even consider the many options that you can take outside of the department. One thing that I do want to mention is some of these courses are taken. Some of these courses are offered at night or in the late afternoons, such as supramolecular materials and nanomedicine is offered 1 to 2 nights a week in the evenings. As I mentioned, my metabolic systems course is offered in Friday afternoons, and Carmo Pereira's course is offered in the evenings as well. Reaction engineering, But some of these other courses, such as the nanobioengineering lab, it's difficult to offer that in the evening because of faculty needs and the lab component. So, for example, that and the regenerative medicine are typically taught during the day. So this is sometimes, we recognize this is sometimes a challenge with the EP students. So if you can't get off time with your work, we understand that may be possible, then you can substitute some other courses from another major or within the department for these electives. But we certainly have a number of electives available for students depending on your level of flexibility for taking courses during the day or in the evening. Okay, I'm going to roll here. Next slide, Ken. Okay, I think one thing that I guess my picture is there, so I want to mention that. As Ken said, the courses are offered at the Homewood, primarily at the Homewood campus, which is in a nice residential area within, I would call Midtown, maybe northern Baltimore area. It's in the red map. It's easily accessible from I-83, 95, and then a number of major roads within Baltimore. Parking can sometimes be a challenge, but certainly given the residential nature, parking is available through some of the parking garages and other areas around. And many of the students commute in to the campus or take other buses. We have Hopkins buses that come around campus as well. This presence of the Homewood campus allows students from all over the Baltimore and Washington area and points beyond to take advantage of our course selections. I think that's it, Ken. Is there anything else for me, or maybe I'm kind of out of breath now, so I'll turn it over to you.
I think that covers it well. Thank you very much. So I'm just going to run through some logistics with everybody. Some important dates that are coming up. It's too late for the summer term. That started at the end of May, but fall is quickly approaching. And if you are interested in starting the program this fall, I would encourage you to get your application in as soon as possible. The fall term doesn't begin until August 29th, but registration opens July 7th. So the sooner you get your application in, the better, because we can process all the paperwork, get you into the program in time to register on July 7th. If fall is a little bit too early for you, there's the spring term, which begins at the end of January, but the registration for classes opens October 27th. This is a good opportunity for me to mention that we do have 3 academic terms throughout the year. Fall, spring, and summer. Now, with the Homewood-based nature of some of these courses, it may limit the availability, because I guess the full-time program doesn't offer summer courses. Is that correct? So at any rate, we do have 3 terms, and more you take EP courses, the more flexibility you have. In terms of the application, it's a pretty straightforward process. The application is available online on our website, and there's the URL right there. If you fill that out, hit submit. The only thing we need at that point is your official transcripts from all of your college studies. And typically what you can do is go to your undergrad or other master's degree studies. A lot of times they have it available online where you can just fill in the information and have it sent directly to us. And then the last thing is, well, actually there isn't anything here. We used to have an application fee. It used to be $75 just to apply. We decided to do away with that. So you'll be happy to know it costs nothing to apply. So we're really just looking for the online application and your official transcripts, and you are good to go at that point. In terms of financial aid, what are your options? Well, there are 5 options here. Unfortunately, we do not offer any scholarships in the Engineering for Professionals division. So that leaves you with federal financial aid, the National GEM Consortium, veteran benefits if you fall into that category. A lot of times our students rely on employer funding, and that can be partial or total funding from your employer. It depends on how generous your employer is. And if all else fails, there are personal loans that you can take out. But these are the options that are available at this time. And just to give you a sense for what it's going to cost you, our current tuition is $3,880 per course. As was mentioned, you need 10 courses to complete the degree. Factor in that we raise tuition a little bit each year, you're probably looking at about $40,000 when all is said and done. And so with that, we'll open it up to questions. It doesn't appear as though any have come in at this point. So we'll give you a few minutes. If you have any questions you'd like to ask of me or Dr. Beaton Banton, we're here to answer.
Does that mean we did a really good job, Ken? Is that what that means?
I think so.
Yeah, please don't hesitate. I mean, this is really the best time to get these kind of questions. You know, what the difference is between different degrees, what the different options are. This is certainly a good time to you've got both of our kind of full attention. Typically, what happens is I'll meet with the students often by phone after they begin their program, and then most of the communication is often done by email because of students are away. I'll meet with them maybe at the beginning, at the end of their program, but much is done by email. So it's a real opportunity to get those questions in. So certainly encourage you if you have any concerns or anything to let us know now, and we can help answer them. I'm going to go back to mute.
So one thing I'll mention as we're waiting is Michael mentioned that we're working on developing online courses for this program. In case you're wondering how we do that, the software we use is Blackboard. Now there are a lot of things you can do with Blackboard. It's sort of a very robust foundation. But Engineering for Professionals actually has a Center for Learning, Design, and Technology. And what that means is we've got a team of about a dozen to a dozen and a half employees who are instructional designers and instructional technologists. And what they do is they work very closely with the instructor to build the online course. The instructor is, a professional or a master of their subject area, but not necessarily a master of building an online course. So we want to make sure that they have the direction and the resources available to them to build a really meaningful online learning experience. And so that's the way we approach it here at EP. I think it's a fairly unique aspect to how we do things. Okay, so a question came in. There was some mention of a couple classes available online. Is there a plan to make the full ChemB program available online in the future?
So is that a question, Ken? Is that a question?
Yeah, that was a question that just came in, asking if ChemB will be available fully online at some point in the future.
Just a second, my wife called, asked me about dinner, so apologize. So, I think there will be some metabolic systems biotechnology is being converted to online right now. So that one will be online. But to be quite honest, it would be, I would be overstating if I were to say the entire program will be online within 2 years. I think that would be overly optimistic. Here, answer the phone. It's Mommy. Tell her I'm on a meeting. That would be overly optimistic to expect all the program to be online in 2 years. Yeah. Okay? So we hope to take one course at a time. So I would expect about a course or two per year to come online. Okay?
Yep. And as was mentioned, we give you up to 5 years to complete the degree. So if you have the luxury of taking that full amount of time, more and more courses will be available online as you go. As Michael mentioned also, if you are to take electives outside of the ChemB program, a lot of those are available online And the biotechnology program, which is actually offered through the School of Arts and Sciences, I think has quite a robust offering of online courses. I think you can complete that degree fully online at this point. So there is some flexibility there.
Yeah, so that's a good point, Ken. So for a person that wants to do it, to do the predominance of the and we've had students that actually have done this. You could conceive of taking, given the fact that metabolic systems is going online, you could conceive of 6. I don't want to get held hard and fast to this, but you could conceivably see that 6 of your courses, even right now, would be, or within the next year or two, would be online, and then 4 of the courses would be on the campus. So what I've actually had students do is kind of take a semester and then take all those courses. You know, they took one semester and just took all of the courses on the campus, or they would take a train down or something and get all of those done one semester, and then they did all the other courses online. So at least half, if not more, of your courses can potentially be taken online. It's just a lot of the courses in chemical and biomolecular engineering are not online yet. It's oftentimes somewhat difficult to convince my colleagues to do a video course, but it's changing, and I would expect in 5 years that the majority will have options for the majority of the courses online. Over.
Okay, well, as we wait to see if any additional questions come in, I just want to reiterate a couple of things that I mentioned earlier. Oh, before I do, it looks like we just got another question. Concerning the initial entry competencies, must one prove competency to be allowed into the program? Besides transcripts, how?
Yeah, that's a great question. So the typical way, besides transcripts, is they take a course at a local chemical and biomolecular engineering program. If their major is, and it also depends on their major. So if you're a biology major, we would like to see a courses completed through differential equations. But if you're, let's say, a biochemistry major, and you say, well, I've taken most of the courses related to chemical engineering and thermodynamics, then I can just assume a competency. So there's a variety of different methods. Ultimately, if a student is a good student in good academic standard from their undergraduate degree, and they've taken 3 of the courses, Calculus 1, 2, and 3, and they said, well, you know, I've learned differential equations on my own. You know, we have a discussion of that, what they're going to do, and sometimes, in rare cases, we're willing to forego the actual course themselves if they do some type of independent learning for them. That's not the rule. That's more the exception. And it certainly would have to be accompanied by a demonstrated competency in the prereqs going into that. So there is some flexibility. That's why I talked to Ken a lot about these slides. So there are different ways to demonstrate competency, but ultimately the competency is going to be demonstrated by your ability to perform in courses like mine, metabolic systems, biotechnology, and chemical reaction engineering. So if you don't have any background in reaction kinetics, you're going to be at a severe disadvantage in that class. If you don't have a good background in thermodynamics, you're going to be at a severe disadvantage in interfacial phenomena. So the ultimate judge will be your performance in the graduate courses. So in a bit, it's somewhat of the honor system. It's an honor. I would say a qualified, as Reagan used to say, trust but verify. So it's mainly, we encourage you to take courses at undergraduate programs. If that's not convenient for you, there are other ways to demonstrate competency. We're not going to restrict you from your dream through that. You can also take courses at Hopkins as part of the undergraduate program at Hopkins. So there's a number of different options. It's typically through courses taken at a local chemical or biomolecular engineering program, or courses in your undergraduate transcript, but there are other ways to demonstrate, especially if you have a good record in that area. Great question. Over.
Okay. Well, one thing I do want to mention before we conclude for the evening is that we are recording this. So if there's something you missed during the course of the presentation, we will send this out to you via email after the session's over, probably in the next couple of days. We'll also make this available on the ChemB homepage on our website, as well as on our YouTube page. So you'll be able to find it in a few places, one of which is in your inbox. But we do like to record these just so that people can go back and reference them, or send them on to friends and colleagues who might be interested in the program as well.
And also, I would just add, I guess your email information or contact information is available, right, Ken? So I encourage people to contact your office, and then they can also try to contact me, but also to contact you simultaneously. Because I get a lot of emails in case I miss it, and your office can forward questions to me as well.
Absolutely, that's absolutely right. My contact information will be in the email, and if I can't answer your question, we do also have the admissions representatives who help out with this program. They can often answer questions about financial aid, the application process, and things of that nature. So just as a quick reminder, I showed these dates earlier, but I'll show them again. The fall term registration opens on July 7th. That'll give you plenty of time to prepare for the term beginning on August 29th. And then if you are looking ahead to the spring and you want to start in the spring, registration opens October 27th, and the term begins at the end of January. So just a couple of dates to keep in mind as you're planning this out. I know it's not something that people enter into lightly. It is a time commitment, a financial commitment. So we want to make sure that you're prepared to enter the program. And if there are no other questions, we'll go ahead and conclude for the evening. I'll point out that at the bottom of this slide is Dr. Beaton Banton's email. Again, if you have something urgent, feel free to reach out to me, and I can put you in touch with either him or the admissions staff. But one way or another, we will be able to answer your questions. And so with that, I guess I'll go ahead and thank everybody for joining us this evening. I want to thank Dr. Beaton Banton for joining me in the presentation, and we hope you have a wonderful evening. Thank you very much, everybody.